absolutely brilliant seeing everybody here. Thank you very much for joining us, and absolutely delighted too about tonight's talk. I think this will be the highlight of my program this year, though I fear I'm kind of unfit to introduce our speaker. I absolutely hated history at school. I've never visited the Natural History Museum, though I'm going to put that right by the end of the month. And though I haven't been to the Natural History Museum, everything I've been learning about it recently is just so exciting. I've been blown away by the breadth and extent of what Natural History Museum does. So I'm really looking forward to the talk tonight. Our speaker is Tim Littlewood. Tim is Executive Director of Science at the Natural History Museum. He has 2 degrees from Manchester University, and I'm intrigued, Tim, by another one. I'm sure everybody on the call would want to have a PhD from the University of West Indies. So maybe you can tell us a little bit about that in the lead-in to your talk. Now, Tim, I think on Tim's to-do list, probably number 1 is to build an extremely large and complicated building on Harwell Campus. Number 2 might be, trivial assignment of transferring 27 million specimens to the campus. Number 3 may be maybe the most tricky one of all, relocating hundreds of people. But I think all that means is that Tim may have a few things on his mind these days, and it is exceptionally good of him to devote time to us for this talk tonight. So Tim, a very, very warm welcome to Wantage. You must come and raise a glass with us in one of our local establishments on another occasion. So Tim's talk tonight is the Natural History Museum is coming to Harwell. Tim, welcome.
John, thank you very much. That's a very lovely and generous introduction, and thanks also Faith and others behind the scenes who've made this possible. Really good to join you all. Sorry not to be physically present with you in your normal environment, or indeed to be able to raise a glass afterwards. So yes, John, just to those 4 points. First of all, my PhD at the University of the West Indies. So when I was finishing my degree at Manchester, my head of department was the external examiner for the University of the West Indies. And I'd always been struck by the fact that he'd left to go to either Jamaica, Trinidad, or Barbados every year for a few months. And I decided that I definitely wanted to work in the tropics. And I managed to get a British Council scholarship, which was originally for 2 years, to go and work on oysters and cultivating oysters, aquaculture in Jamaica, which became 3 years thanks to the British Council, and then 3 more years from the Canadian government. So that's where I learned about parasitology, which is what my main area is. But yeah, a long, long time ago. So let's crack on with this talk, and I will upfront apologize for its mixture. Some of it seems rather corporate, some of it seems rather flippant, perhaps in places, bit of history, but hopefully a flavor of the kind of science that the museum does and that it's looking forward to doing as it moves to Harwell, or a piece of it moves to Harwell. So many of you, I hope, will have been, unlike John, will have been to the Natural History Museum and will have been welcomed by either Diplodocus, the dinosaur cast that used to be in the central hall, or Hope, the whale here that you see hanging from the central gallery ceiling. Many people know us for our galleries, and you can see some of our ongoing temporary exhibitions at the moment. Our Broken Planet, which is looking at the Anthropocene, Fantastic Beasts, which is a sort of the magical side of and the fictional side of nature as seen through J.K. Rowling's eyes, but also through biology and natural history. And we've just closed this year's Wildlife Photographer in preparation for next year's. So the majority of our 5 million visitors, public visitors, this is pre-COVID, 5 million visitors, will know us for our galleries and our exhibitions. Behind the scenes, there are 300 museum scientists who are involved with looking after the collections. And I'll be looking at that in a bit more depth through this talk and the kinds of science we do with those collections. Those collections are world leading. We get over 5,000 research visitors per year to come in behind the scenes to look at the specimens and to reference them for a variety of reasons. And one of the challenges we have and why Harwell is a useful thing for us is that we want to make those specimens increasingly available to wider audiences. Doing that by loans through the post is difficult, particularly for precious and rare and large specimens. Having people traveling constantly is also very difficult. So digitizing those specimens, making sure they're available through a catalogue physically is tricky, but doing it digitally online and making that information useful for people to see what we have before they plan a visit or ask for a loan is increasingly important. And about 80 million specimens, 4.5 million or so have been digitized so that they can be discoverable, some with images. And of that particular data set that we have on our records, over 27 billion records have been downloaded. So we know that digitization really opens up our collections much more to the scientific public, but also to the lay public interested in understanding what we have behind the scenes and what we've accumulated since the middle of the 17th century.
Tim, forgive me interrupting one
yeah.
second. I've just had a comment on the chat. If it's possible, I don't know whether there's a button you can press to show the slides full screen. Would that make sense?
Have you got my notes instead of the other way around? Let's do that again. How about that?
Great.
Perfect.
Thank you, sir.
I do apologize. I'm working with two screens and I'm obviously got the wrong one. Let's do that. Okay, so there you go, Central Hall. Now we'll move on from there. Thanks, John, for that. Let's move on. So a little bit of a snapshot of what we'll talk about today. There's the outside of the museum, and then a little bit of a taster of what we have behind the scenes and the activities we get up to. Collections, library and archives, data that spans a global collection, activities all around the world, from around the UK to that picture there that you see is actually administering drugs in Benin as part of a Bill and Melinda Gates Foundation project that I was part of for the last 5 years. So let's dive in. Now, if you do the corporate side of the NHM, since the early part of 2021, we started with a new vision, recognizing that the planet was in a pretty dire state, and we pledged to have a vision that was of a future where both people and planet thrive. And the broad NHM vision, which largely takes into account all of our activities, is to create advocates for the planet. Of course, this evening I'll be speaking predominantly about our science, and then our strategic priorities. You can see in bold there, those elements that are really key to this presentation are securing the future of our collection. We have, through the British Museums Act, the legal requirement to look after our collections. We want to transform the study of natural history in terms of applying new technologies and developing new technologies that unlock our collections analytically, and moving towards solutions for and from nature. I'll come back onto that in a moment. And of course, engaging and involving the widest possible audience, however we can do that. And indeed, this evening's presentation is just a very small part of that one. So as regards science, when Hans Sloane, I'll introduce him to you in a few moments. When Hans Sloane left his collection to the nation, he'd left a collection of material that had been his lifelong work looking at natural history specimens, and I'll come on to what that was about. And he was a physician and was always interested in understanding how to use things from nature for solutions. And of course, in the mid 17th century, most physicians were good natural historians, and many of them indeed were botanists, because they had to understand what medicines they could make from local botanical specimens, plants, plant remedies, and so on. So just going back to NHM science, we've pitched ourselves as looking in the future for solutions from nature, problems that we need to solve for a future where people can thrive, and solutions for nature where we want to provide solutions for nature to thrive. And then our timelines in terms of Harwell are moving towards Harwell. By 2026-27, we expect our building to be delivered. And in 2031, which is where our current strategy takes us, we'll be celebrating 150th anniversary at South Kensington. But I'm going ahead a little bit in terms of our history. The other element that I just wanted to pitch, some of you may have read a book by Simon Sinek, which asks companies and organizations, why do they exist? Not what they do and how they do it, but why they exist. So our creating advocates for the planet and looking for solutions for nature and from nature is our why. We do that by looking at nature's past, present, and future through our collections and through our specimens. And the predominant feature, the common feature of what we do with our specimens is to identify, classify them, connect the dots around specimens, how they interact, how they work in natural environments, and to solve problems associated with ecology and environmental sciences, evolution, biodiversity, and so on. This cartoon came out shortly after COVID began, and it kind of sums up the planetary emergency. It certainly sums it up from a COVID perspective, and it's quite a controversial cartoon, because not because of the different sizes of the tidal waves and the order in which they were coming, but the fact that the recession was probably the least of our worries, and indeed COVID-19, although we might not feel that way at the moment, is also the least of our worries when we consider what is coming around the corner in terms of major changes to the climate and the potential collapse of biodiversity. Some horrible statistics around there in terms of just last week, a statistic that resonated with me as a fish parasitologist: a third of the species of sharks on the planet likely to become extinct within the next 15 years or so. I mean, just horrendous numbers that are being bandied about. So NHM origins, I mentioned Hans Sloane, born in the middle of the 1600s, was the first and only person to hold both positions as president of the Royal Society and the president of the Royal College of Physicians. A very clever and astute individual who was all about commerce, but also about natural history collecting. So he managed, one of the few people who can claim to have used and developed a recipe for milk chocolate, was one of his major claims to fame. But the British Museum was, or the Natural History Museum was originally part of the British Museum. We were the British Museum Natural History Division, and the building in South Kensington was opened in 1881 specifically for our natural history collection. And it is that anniversary in 2031 which takes us to 150 years at South Kensington. So just a quick thing here. I'm sure many of you, I could see from the background of some of your images that you are collectors, books, a lot of you, but items on your shelves in all kinds of ways. And I'm sure you've all got reasons for why you collect things. This is a list that's not at all exhaustive, but it is something that is common to our collections. And it is often these questions that ask us, we ask ourselves when we're walking around as children, as adults, as amateurs, or even as professionals. What is it? Where does it come from? How is it related? And so on. And that intrigues us about understanding the natural world. And that essentially is very simply the basis of of natural history science. It's understanding those connections and how things work. From a physical perspective, apologies for this busy slide, but since 1886, when we opened, we've had a vast increase in numbers of individual people, over 5 million, as I was saying, prior to COVID lockdowns. So from 382,000 to 5.5 million visitors. But our space, the physical space that we've had available for our collections, has not even doubled, from 17,000 square meters to 24,000 square meters. And this is really what's caused the problem, has caused many problems over the years in terms of our relentlessly growing collection. And it's not a collection that's growing randomly. It is one that is has a strategic direction in it, understanding various parts of the natural world and various reasons why those collections have grown through time. And of course, as you might imagine, with a building that's essentially Victorian, when we start looking at what happens, you get a picture there of a flood in the basement, destroying or threatening specimens and archives. We've got drawers that are packed so that we've got layers upon layers of specimens and a lot of compression going on. And we have asbestos in the building, and basically an unsuitable condition for most of our collections, and indeed, therefore, for our scientists and curators who look after the collections and use them. In terms of sheer numbers, we have most of our large specimens in a storage space in South London, which is not open to visitors. It's open to science visitors, but not to the public. And the sheer numbers are pretty scary. So 35 million specimens of insects. Most of those are in fact, all of those are in South Kensington. Our algae, fungi, plants, our botanical collections are in South Kensington. And the majority of our zoological specimens are in South Kensington too, but large collections of our vertebrates, you see an image of our taxidermy, are in South London. And we also have bird collections in Tring, which is the old Rothschild home, Tring Museum. So we have I've starred there in red the specimens that are tagged for moving to Harwell, which will be relevant to perhaps some questions in terms of what we might be doing at Harwell later. That was the life science collections. The earth science collections, predominantly mineralogical and paleontological, but also some planetary science material, meteoritic material, is smaller in number, but no less important for that. 10 million earth science specimens and over 5.5 million specimens in our library and archives, some of which is just where you have a couple of talks unto themselves just talking about that material. So let's go back to those three questions. What is it? How is it related? And where does it come from? Every specimen in those 80 million will have been collected for a reason and will have been retained for a reason. And the specimens have excellent provenance. Usually we know who the collector is, we know where it came from, they will have been identified, there will be notes associated with those specimens, there'll be publications from those specimens. And it's a bit like the Antiques Roadshow when you go up and say it's a Rembrandt, and we know it's a Rembrandt because of X, Y, and Z. Almost all of our specimens have a rich history, and you only really need to start speaking to a curator and a person who really understands the specimen, then you begin to understand the value of that specimen and its place either in biodiversity or in evolutionary history or geography or in terms of climate change or pests or predators or you name it. There'll be something about every specimen that will merit us having it in our collections. The important part is that almost all of these are act as reference material, and of course they're reference material for geography, where it was found, and reference material for time, when it was found. And bear that in mind for some of the pieces later on as we talk about. So we've got baseline data of 250 years of collecting across the natural world, both geological and biological. And so if you map some of our data onto a graph there, and those little light points, you can see it's truly global, both in terms of terrestrial and marine systems, and indeed extraterrestrial systems too. So along with other museums, we consider ourselves to be a piece of science research infrastructure. It's difficult to see it that way because it's rather like the Bodleian Library, but with the reference specimens in it. When you start adding all of that information, the geological, biological, cultural diversity, and all those dots being connected through space and time, you then have a rich history of change through the planet, all the way to those 4.5 billion years, which are coming from meteoritic samples outside of the solar system, arriving randomly and occasionally, luckily, on the planet, and even more luckily, arriving into our collections. So if we take a range of specimens here, whether they are library and archives, or whether they are the information that we're getting out of those specimens, take the museum specimen in the middle there, and then there are a suite of disciplines that generate additional information from those specimens, what they're used for. And if you then begin to think of this in a digital world and a data world, and the kind of world of Google, where you're quite happy to click on a Google of a name of a specimen, Google happily brings all of that information together for you. A lot of that information, of course, just like any Google search or a Wikipedia search, you want to know that it's true, and you want to know that it's got good provenance. The key thing about the information around a museum specimen is you can always go back to the specimen. If you don't believe it, you can go back, you can test it again, you can check it, you can verify it. So those specimens, even though they may have been collected for quite simple reasons and quite different reasons, become even more important and more valuable as time goes on, because there's an accretion of information and knowledge around the specimen. So we have this kind of virtuous circle in science, in collections-based science. If you start with a collection and then you're applying your science to that collection for whatever reason it might be, that's looking at change predominantly in space and time, or for reference points. And then you're looking at new innovation techniques, particularly the kinds of things that we're seeing increasingly being developed at Harwell. This begins to allow us to interrogate those collections in a new way. And if we're then looking, as we are at the moment, with a focus on solutions-led approaches, for example, looking for signatures of disease resistance, or drug resistance, I should say, in parasites, something that's close to what I do, that using that collection to develop that information then drives another question, which is I need to go out and collect X, Y, and Z. So you have a virtuous circle here where your collections, your data to information to knowledge will generate the need to go out and collect more. And if we think about the amount of money that the UK spends, and it is billions, on collecting information and specimens, whether they're from the environment or whether they are from medicine, or they're all over the place. Those collections, most of those collections will generate data, but very few of them actually find a home such that they can be preserved, curated, and looked at it again. We can't save everything, of course, but being judicious about having collections for future interrogation, particularly in a changing environment, is really important. So unlocking our collections is key for us. That's done through the analytical side, but unlocking them digitally is important, and uniting them digitally is important. And then collecting for the future is one of the biggest challenges. If you ask a curator, what should you collect today for tomorrow, you'll probably never get the same answer twice, but it's a good challenge. It might be that we should be collecting material that is becoming extinct, or material that we know is going to threaten our crops in some time. So, for example, should we be collecting ash die down fungi so that we can understand how they're changing? Asking those questions is essentially the foundation for collections-based science, which is what all museum research is, but particularly natural history museum research. Apologies for the small font on this, particularly if you've got iPads or anything else, but this is just to point out that we have those three sites. We've got South Kensington, we've got Tring, where our bird collection is, and what we'll be moving in terms of those 27 million specimens to to Harwell will include our invertebrates. This is all the earth and life sciences, so the paleontological and the recent material. All the invertebrates except our insect collections. The mammals, because they're large, bulky, so our whales and skeletons and skins and bones and spirit collection. Our micropaleontology collections are ocean bottom sediments, and what is an increasingly important collection is our molecular collections, our tissue collections, moving there as well. We're trying to understand exactly what we need at the moment in terms of our facilities, so that we don't unnecessarily duplicate some of what we have or what is already at Harwell, but that's all part of that design process to make the best use of what we have. This doesn't mean our science changes. Our science goes on across each of the 3 sites, but the collection area where they're going to be best fitted is simply a matter of pragmatic space allocation, and then attempting to make the best use of the new space and laboratories in the environments that they're in. So we're not fragmenting, we're expanding. This is pretty much the same thing at the moment. This is a sort of a simple Venn diagram, not a Venn diagram, excuse me, a diagram indicating the kinds of spaces, physical spaces that we will need for our collections, excuse me, at Harwell, including this piece here, the decompression. As you can see amongst our mammal collections, those drawers that have been doubled up and tripled up with bones, we need the right kind of material, right kind of, excuse me, cabinetry that allows us to decompress our collections so they can be utilized properly. So in short, for us at Harwell, that securing the future of the collections is a key element for us, and delivering a purpose-built sustainable research infrastructure for scientific innovation is what this is principally about. I'll talk a little bit about engagement in a moment, and creating a new hub, excuse me, for collaborations and partnerships, which we're actively pursuing now. And since we went live as to what we're actually moving, we've had a number of people coming into the museum to talk to us about exactly what they can do to partner with us moving forward. So groups like the National Oceanographic Centre, Centre for Ecology and Hydrology, and so on and so forth. On a pragmatic point, one of the main reasons for moving material from South Kensington is not just because the collection spaces are bad, but we've got 3 galleries that are currently being used for collections. So by moving our collections into bespoke collection spaces, South Kensington gets back 3 galleries, and that's really important for that public offer and allowing us to enhance our public programme. I'd also draw attention to the middle block here, which is the direct engagement at and from Harwell. I think when we mentioned that we'll be coming to Harwell, some people felt that we were the visitor side, the engagement side was going to be placed in Harwell. And it is to some extent, in that we want to make sure that we've got the best possible digital state-of-the-art studio facilities for our scientists to interact globally as they do now. I'm gonna have some water here, excuse me. I noticed John sensibly has a beer. But a state-of-the-art studio facility for us to be able to broadcast and teach is one key element. And of course, like many other organisations at Harwell, we're keen to have a visitor centre. And perhaps more importantly, we're really keen to start working with our neighbours at Harwell and environments to be able to push cutting-edge science across all our platforms. So our digital reach at the moment, just this year, since January, we've had over 9 million web hits to the Natural History Museum, unique ones, and we're increasing that web, or rather that digital interaction or digital audience by 9% a year at the moment. So it's just over 16 million hits last year, and this is growing. So being able to use our wide audience to talk about not only our science, but the science of our partners and colleagues and friends at Harwell will be a key issue for us too. I'll rattle on here. So what science do we actually do? We've got this triumvirate of 3 organisations, or 3 buildings, I should say, ultimately at the Natural History Museum, that triangle with 3 triangles that you see there. We work with other national organisations who are collections based. You'll not be surprised to hear that we work closely with Royal Botanic Gardens Kew and Edinburgh, and regional museums and national museums of Scotland, Wales, and indeed Northern Ireland. So our global collections, our UK global collections, are great, and although we as an institution we can claim to have 55% of the UK's natural history specimens, what's really important is that they are united with other specimens and other data collections, both nationally and indeed internationally. So I'm hoping much of what I've written there on the left in terms of that solutions-based approach to science makes sense. Understanding biodiversity change through time, and I'll give you some examples in a moment of the kind of things we're doing. Looking at biodiversity and health, resourcing the green economy, which is really about using non-renewable resources in a sustainable way so that we can move towards a circular economy. Genomics, you may have heard about a few times in some of these Café Scientifique presentations, and I'll go into a little bit of that. Image analysis and phenomics, I suspect, is relatively new, the phenomics side. It's an odd word, but it's essentially the morphological, the shape and form side of genomics. It's why organisms are shaped the way they are, and what are the limitations that brings, both in terms of their ecological and evolutionary trajectories. Planetary systems, digital data and informatics, a focus on UK biological and geological diversity, which is married to the second one there with citizen science. We've got a very strong group at the Natural History Museum who are expanding STEM education for children all the way through to older children, I should say, older adults who have a good childlike interest in the natural world. And I don't mean that in a derogatory way, but a good enthusiasm and curiosity of the natural world. We have sort of faltered a little bit over the years in terms of our cultural heritage research, but that rich collection of specimens gives an insight not just into the natural history, but those who collected the material and what they were doing around the world. You can imagine much of our collections coming from a colonial history, and the postgraduate education and training is also key. So in looking at each of our physical sites, that interaction between the people we have who are capable of looking after collections and interrogating and asking questions, that proximity to collections is facilitated by the laboratories and facilities that are there locally, either in our own institutions or in the environment. So mapping at the moment that triangle at the bottom in the context of Harwell is one of the things that I'm keen to do with partners. So let's take a few examples. So biodiversity change. Many of you will be aware that there are two big international meetings happening this year, which involved the UK government, and the UK is hosting what's known as COP26 in Glasgow later in the year, which will be focusing predominantly on the world's response to the dire loss of biodiversity. Well, as a museum, not only with specimens, but a hankering to unite data around specimens, you may not be surprised that we've been very keen to have a global database that looks at species distributions. And one of the things that we've been doing is to use our own data and unite other people's data in looking at habitat loss and environmental degradation, pollution, and so on, and how all of that affects what's known as biodiversity intactness, how biodiversity responds to each of these human-mediated pressures. And one really fascinating part about that data is not only does it allow us to predict what is happening to biodiversity, but it also begins to suggest opportunities to mitigate against biodiversity loss, but also to measure how interventions to save biodiversity actually work. So coming up with, many of you will have heard about the carbon net zero as a single target to reduce pollution and to combat climate change. That's quite a simple equation, which is basically you don't put more carbon into the air than you are taking away. So there's a balance, and it is that imbalance which is causing climate change and global warming. There isn't a simple index for biodiversity, but the Biodiversity Index, Intact Index, is just one of a few measures that we hope is going to be used internationally to help mitigate against biodiversity loss, to be able to measure what's going on. So that data set is 4 million records, nearly 100 countries, and although it's been soft launched, it will be launched, we hope, in time for COP26 to actually be a genuine contribution, a UK contribution and an NHM contribution to dealing with biodiversity change. That's a good concrete example. I'll give some a few others in different areas. This is a little bit off the wall in terms of biodiversity and health, but I think is relatively relevant still. COVID-19, when it kicked off, a lot of people felt that this was there was a rumor that had come from a lab, and then it was increasingly shown that this was a zoonotic, a wild animal related virus, and that's kicked off a great interest amongst viral researchers to understand the origins of COVID-19. And as part of that initiative to determine whether or not that's true, there's been a European-wide interest in being able to understand where all the bats are in natural history collections, so that they're amenable for sampling and research. We've done this a few times with different diseases in the past. So, for example, chytrid fungus, which has been responsible for wiping out a lot of amphibians. The origins of that fungus, and that's a major problem around the world. The origins of that particular disease were determined almost exclusively thanks to those natural history. I've just been handed a lozenge. They almost exclusively the origins of the chytrid fungus and understanding where that came from and how it spread around the world have come almost exclusively from museum collections. Those museum collections were not made because chytrid fungus was seen to be something of a problem. It wasn't even understood or known about at the time those amphibians were collected, in the same way that nobody understood about COVID-19 viruses when many of these bat specimens were collected. But suddenly they become incredibly important insights into previous baseline information. A little example, more from me, just because I felt I needed to put some parasitic worms in here. So that pretty disgusting bowl of worms is not pasta. That is a selection of Ascaris worms, roundworms. They're anything between 4 and 8 inches long. That came from the belly of a 4-year-old child who thankfully survived. He was obstructing his bowel, and it's a pretty common roundworm. And if you have a look at that little phylogenetic tree that's in there, that's a bit of work that I'm doing at the moment, you'll see Ascaris suum and Ascaris lumbricoides in there. It's a mixture of so-called species. Suum is from pigs and lumbricoides from humans. And you'll see that they're mixed all over the place. The humans and the pigworms are essentially the same species. And therefore, the ability to develop good diagnostics and to track these worms is really important, because if you're treating humans, the question is, should you also be treating livestock? And so the ability to use reference material and the kinds of questions that we ask, what is it? Where does it come from? How is it related? All of those same questions are a fundamental basis for tackling diseases like roundworm or soil transmitted helminths. So the kind of One Health push in biodiversity and health, those interactions between livestock, humans, wildlife and environment are increasingly important. The COVID gave you one example, but this is one that this particular affliction of intestinal worms affects 1.5 billion people around the planet every year. So you can imagine that's not a trivial infection, and it's a disease of poverty. Moving on to the hard sciences, for those of you who are less inclined for the squiggly worms of this world, we're interested also in renewable energy and our ability to sustain what is a move towards green energy, or so-called green energy. And so that little quote at the bottom, I think, is, I'll just read it out. This comes from my colleague Richard Harrington, who wrote this recently. To switch the UK's vehicle fleet of 31.5 million engine-driven, petrol engine-driven vehicles to battery electric vehicles would take an estimated 207,900 tons of cobalt, 264,000 tons of lithium carbonate, 7,000 tons of neodymium and dysprosium, and 2 million or 2.5 million tons of copper. All of this is twice the current annual world production of cobalt, an entire year's world's production of neodymium, and 3/4 of the world production of lithium. To do the same worldwide would need 40 times these amounts. So when we listen to people going, oh yes, let's have lithium ion and more of this and more of that, we've got to ask, where are these non-renewables going to come from? And of course, then you get into the territory of more mining, the opportunity to look at deep sea polymetallic nodules, which are at the deep sea. What is the impact on the deep sea wildlife going to be? Should we be looking more at a circular economy and recycling, or should we be employing modern methods of geomicrobiology to use bacteria to start sequestering some of these elements? This is an area which essentially comes under our resourcing the green economy push. And the first phase is focused on minerals. The second phase will be looking more at food security as we move forward. As you might imagine, with a lot of specimens like pinned insects, we have a lot of what we would call modern DNA or historical DNA, HDNA, in our collections. And so, again, if we're thinking about pinned insects, just as an example, or those bats in a jar, collected over 250 years or so, they still hold their DNA, and we have the ability now with modern technology to be able to get that DNA out quite easily, particularly if we've got modern references to be able to map to genomes. So the world of museomics, a term which came out about 10-15 years ago, is alive and well, and it works not just on short fragments of DNA, but indeed getting back entire genomes. So we've heard about Neanderthal genomes and Denisovan genomes, which are ancient DNA projects, because that's DNA that's over 1,000 years old. But we've got vast quantities of historical DNA in our collections also. And of course, that also allows us to not have to go into the environment and collect fresh specimens again, but to be able to use those markers for all kinds of things, for example, environmental DNA or diagnostic techniques. So being able to take a few liters of pond water and to interrogate that pond water using modern techniques and saying, what's in that water? What species of fish are in there? What parasites are in there? What plankton are in there? And so on. All tagged back to that reference collection. I put in a couple of references there. We are working with the Wellcome Sanctuary of Life program, which is looking to develop or to resolve the genomes of all the UK wildlife, both plant, animal, fungi, you name it, anything bigger than a single cell, looking at those entire genomes. And this Global Genome Biodiversity Network is an international resource where collections like ours are used for reference. Going to the phenomic side, this is a bit of a plug for Diamond, who've been working with one of my colleagues, Anjali Goswami, which is not just looking at 2D images, the kind of photographic images of insects, but using the Diamond light source to very rapidly get through a high throughput 3D image of insects, allowing us to look at evolution, diversity, and extinctions in a much swifter way moving forward. Closer to home, and for the Café Scientifique royalty who are present, the extraterrestrial systems, of course, are fantastically exciting. This is you see the big rock there from Mars with a hole in it, and that's the hole that was bored by perseverance and has been properly secured ultimately for a return mission to bring that back and figure out what the geology really is. Obviously, they've been trying to analyze as much as they can in situ, but using reference material like the meteorites we have in our collections and earth analogues really is a key part of that growth in UK leadership in space science that's happening at the moment. And the museum, with its collections and its commitment to planetary sciences, is playing a small part there. Unlocking our collections digitally, I've spoken a little bit about this. What is digitisation? Ultimately, or at its very basic, it is making sure that our specimens can be found online, that they're discoverable. But they could ultimately be not just the record of that material being found, but all of the information associated with that specimen being digitised and being tagged back. So one of the challenges for us is to be able to do this rapidly. If we continued at the current rate, it'll take us 100 years or 120 years to digitize just our own specimens. So being able to mobilize more efficient workflows is really important and something that we're working towards doing. We've got a small grant now from AHRC to work with other collections in being able to try and develop a UK commitment to digitizing all the national collections in the UK. Hence the map of the UK at the bottom, and that map on the left of European countries is an indication of organisations and countries who are working together for a European-wide unification of natural history collections. Very quickly on our citizen science side, with 5.5 million people coming through the building, not everybody is content, quite rightly, to just look at the exhibitions. They want to interact and they want to learn more about their own environments and their own local biodiversity and geological diversity. Indeed, we're very committed to supporting that. The majority of scientists in the museum all started just as members of the public with a keen interest in natural diversity. So our ability to work with schools and with other partners and corporate partners, indeed, to be able to bring science into the hands of citizens is a key piece. So this is really making sure that we work with partners as broadly as possible in empowering the citizens, UK citizens, to be able to develop and deliver actual science for meaningful research and impact. And I'm close to finishing, so don't panic. Just to say, we do have a good, strong interest in postgraduate education. This is just some of the doctoral training partnerships that we're part of, distributed around the UK. And now with a move towards expanding towards Harwell, you can imagine we've got a renewed interest in really growing our graduate numbers, courses and partnerships, not all just at the postgraduate level, but also at the amateur and professional level too. So we're hoping there's something in here for everybody as this expands. Just a reminder, this is the kind of material that will be coming to Harwell. I think some of it is quite glorious and visually exciting, so we'll have to make sure that at least some of it is on show to people visiting the building, not just knowing that it's in there, but actually showing it. And I'd be interested to hear from this audience what you think or how you think we should do that. And I think, no, I'm just going to go past that one, remind you of that, and I will probably stop there.
Tim, that was just such a great talk, and privilege for us to have you give the talk. I kind of need to confess that I'm just flicking to a sort of gallery shot, if that works for everybody now. I should remind everybody we're still being recorded, so mind your language, everybody. And you have questions, put them in the chat, would be great. I confess to having been critical of Natural History Museum in the past for the failure to engage me and compel me to come and visit. And it's clearly part of my missing education. When I see the slide you put up, major areas of science, I'm actually not sure how on earth you could kind of rebrand Natural History Museum to get across the amazing range of stuff you do. And I just wish I was a generation younger, that I could spend more time getting to know Natural History Museum more. I'm really looking forward to visiting before the end of the month. I've already been a customer of the shop for things for my grandkids, and I can't wait to take them to the Natural History Museum in London. But what an amazing place. And having a foot in the camp of Harwell Campus, I am really, truly excited at the prospect of you being there and engaging with. I think there's just so much potential for the community on Harwell Campus that's there already and still to come to engage with Natural History Museum. Terrific stuff. Faith, I know there was one question about,
yes, Ian has asked something. Can the Biodiversity Index, BII, be explained in a little more detail, please?
Yeah, I've put a link in there. I'm poorly qualified to discuss it really, but it essentially it's a health measure for biodiversity. So in an area that is unaffected by any human activity, there will be a baseline number of species associated with that environment. If that same environment is being utilized in some way, for example, for agriculture or for building or urbanization, you can measure the same species, the number of species per unit area, and that will give you an index as to how complete the biodiversity is. So if there was no change to the biodiversity, your biodiversity intact index is high, and that it is by its nature intact. And so as that index goes further and further down, as an environment is further damaged, there comes a point when the biodiversity cannot recuperate and cannot get back to its normal state, and it is now sort of moribund and sort of a biological desert, if you will. So that number is tractable through space and time for any particular areas, and what they're trying to do in the museum is to give a satellite image for any country, and to be able to say within, actually, I think it's a really quite high resolution. It's like a possibly 50 to 500 meter resolution to say what that index is for a particular area. So it's helpful for planning, but it's also helpful for conservation in terms of where activity should be avoided or taken place in terms of human activity.
Okay, thank you. There is another question, but I just wanted to squeeze in one myself. So the visitor centre, is that likely to be open all the time? And is that, I get the impression that's not like a big gallery, it's just a small showcase.
It'll be small, I'm afraid. It really is a focus for us to do the science, but we would expect visitors to come. We would want to be, just like Diamond has a visitor centre that allows people to move in. And I think there's a greater appetite on campus generally, knowing how big the campus is getting, for being able to develop more interaction with the scientific organizations. So that's a separate conversation yet to be had with Harwell for future iterations, but actually we'd be very keen to help support broadening that interaction and engagement with science, whether that's digitally or physically on campus.
Faith, I think your question tees up the absolute necessity of involving Sophie Palmer and Vicky Stoll, who I see are on the call. So unaccustomed as they are to visiting Wantage Café Scientifique, since they take care of the massive outreach program from Rutherford Appleton Lab and the events program there on campus. They probably have some ideas on where this may go, or maybe just put a marker down with Tim to have another conversation another time. Sophie, Vicky, where are you?
Just here. Hi, John. Hello, everybody. Tim, that was a fantastic talk. Thank you so much, and always happy to chat about possibilities. We've already been talking to some of your colleagues, and I think we've got a talk scheduled for later in the year as well.
That's good. There's a question from Mark Reynold. Can you expand on the ocean sediments collection available at Harwell? And Tim's actually sent a link for that. I don't know if you want to say anything as well.
Yeah, it's rather spectacular, actually. Britain were very much part of a lead. Obviously, our history is naval and marine in many ways, and in terms of discovery, literally the discovery expeditions, but also HMS Challenger expeditions looking at deep sea sediments and deep sea, how mapping the ocean floor, which was happening in the 1870s. Every time they were doing that, they were taking sediment samples from the ocean floor, and many of those have now reside with us in South Kensington and will be moving to Harwell. And they are still of use because they are a microfossil and geological record of what the deep sea was like at the time. So I don't think we'd be expecting to see plastics at that point, and I don't think that's something we would be using it for. But in terms of faunal change, so climate change, for example, even at the deep sea side, there's a record of what was going on in the deep sea at that point. And that particular set of collections, because it was so rare at the time, and it still remains rare because the ocean bottom sediments are not readily collected, and certainly not systematically collected. They become because they are so rare, they have such a value for geologists and marine oceanographers to understand how the circulation has changed, and how faunal assemblages, animal assemblages, planktonic assemblages in the water column have changed too. It's the kind of information that you would get from the geological record, but you very rarely get from the recent living record.
Question.
Thank you.
Oh, sorry, Faith, is this an appropriate time? I am compelled to ask the cryogenic question. Being involved very much in the cryogenic community, which isn't quite as creepy as it sounds, Tim. I'm guessing when I saw mention of cryoarcs, that at least part of the collections will need low temperature preservation.
Yeah, so we have a modest facility at the museum, which is very much modeled on the one that both the Smithsonian and the American Museum of Natural History have in the US. And that's a liquid nitrogen, very large dewar flask system. I think, you can imagine with a collection as vast as ours requiring quite specific kinds of climate control and temperature and so on. We're always keen to find solutions that if all the electricity goes off, the collection will be fine if you just leave it alone. So in terms of the cryo collection, the frozen tissue collections and the DNA collections, most of that is under liquid nitrogen vapor. And unfortunately, our modest facility at the museum is part of the building that is really not fit for purpose and needs to come down. So we are, the good news, well, the bad news is that's going. The good news is that we can expand it because it really just didn't have enough room anyway. And there's an increasing need to have frozen tissue collections, particularly in the age of genetics and genomics. So us being able to move forward, and I do look forward to working with you, John, on this in terms of expanding what that collection should include and what should it have in it, whether that's tissue collections, DNA collections, next generation sequencing library collections, live tissues for tissue culture, for example, which is really one of the most important parts for conservation genetics and genomics. That could readily be something that we could look at. So CryoArcs, the specific project, is funded by BBSRC and involves UK zoos and universities. That's really about trying to get hold of rare tissue samples that are then ready to be applied for conservation genetics and genomics. So saving organisms that are heading for extinction. But that's just one wing of what a frozen tissue collection could be.
Brilliant. Well, I can assure you that in coming to Oxfordshire, you're coming to a happy cryogenic place, arguably the best cryogenic place on the planet. Sorry, Faith. There's another question or two in the chat.
No, I don't think so. I just wanted to ask though, so you said that basically the whole setup will be changing, that the Natural History Museum in London will be gaining some galleries because some of the collections will be moving. Tring has always had its own sort of little, I don't know, individual nature. I just wondered if that would be changing much.
Yeah, you're right. It does have its own nature, and it's a quaint and lovely, lovely place. The collection itself is spectacular. I think anybody who's interested in the history of natural history loves it. I think the really good news, because they were quite nervous, my life science colleagues at Tring, that they had to move the bird collection out there some time ago, and I think they've got very comfortable, thank you very much, and did not want to think about possibly moving. So the great news is, A, they're not moving, but most importantly, because they're not moving and we're pushing towards this expansion in the future, it really means we can focus on two things for them. One is that we can make it a real centre for ornithological research. So those bird collections become really critical. And in that sort of world of mobilising material and not just having it in one place, the opportunity to work with colleagues in Harwell with our bird material, or in Oxford with the Edward Gray Institute, for example, become enormous. And then the other part, which I think then goes back more to the engagement side, Tring is close to rural English countryside. And as we try and expand what we're doing as an organisation and getting people involved with urban nature and rural nature and biodiversity and geological diversity, we're developing a plan at the moment which is to expand Tring's role and reach in engaging people in essentially the environment around them, the nature around them. So as a strength for ornithological research and another reason to visit them, not just for the Rothschild's collection, which is spectacular, but also hopefully to have more hands-on engagement. That too has a new lease of life.
Sounds good.
Tim, you're going to bring one problem to us here, I think, with all these NICS words. Phenomics?
Yes, Museomics. Yeah. Horrible, isn't
it? We're going to need a new glossary translation guide, I think. But I guess we've time to work on it. Sorry, Faith.
I see Matthew's got his hand up as well.
Oh, Matthew, did you want to ask a question? Or was that? Oh, you're still muted. I don't know if he's going to ask a question or not.
No worries. Sorry if I interrupted you.
That's all right. I can't see any other questions unless anyone wants to add one now.
Ian wants us to join the Onyx Club with Cafe Onyx. There we go. Tim, maybe we should draw a line. You deserve a glass of beer anyway. But and really sincerely, that offer stays evergreen till you are in town. And I think the community is very excited about Natural History Museum coming here, and that there are people on the call. Actually, Susie, where's Susie? Is Susie, are you still there? Susie is the curator of the Wantridge Museum, and she
Susie
may,
Tilbury?
yes, she's not got her video on, so.
Hello, John.
Hello.
I'm here.
What do you think about all this, Susie?
Oh, I think it's tremendous. It's so exciting to have this coming to Oxfordshire and to so close to Wantage.
Yeah,
it's brilliant. I've been telling everyone because I actually took the family to Natural History Museum a couple of weeks ago, and obviously saw the advert for this talk, and I've been telling everyone I've come across that this is happening. So I think it's fabulous, and I can't wait to see it unfold.
Well, that's great, Susie. I think what's really exciting also is that, you know, we will be moving folk to Harwell, predominantly curators connected to those collections. They will have different sets of emotions as they move or choose to move. But you know, you've got a bunch of highly qualified natural historians, all of whom started as amateurs at some point in their life. So the ability for them to interact with a community of like-minded souls is a good thing. And the NHM always, particularly behind the scenes, not just in the front of house, relies heavily on a cadre of volunteers. So you know, the opportunity to go behind the scenes and to actually help and do science is something. Well, we've had many people start their careers with us that way. Let's put it that way. I won't say end their careers that way, although many of our retired folk do that as well. So look forward to seeing some of you behind the scenes too.
Susie, we'll make sure if we bring him to Wantage for a glass of beer, we bring him to the museum for a cup of coffee too.
Fantastic, great, and some cake.
That's good.
it is a good museum. Okay, is there anything else anyone wants to say? We're getting some people say it was a very good talk. Thank you, Tim. I think, yeah, excellent talk. I think we all felt that, so that's great. John, should we talk about the next talk now and plans for the future?
You go for it and then we'll wrap up.
Yeah, so we've met with the Beacon and hopefully they'll be able to install this large screen that Phil Hutchison has very generously donated. So that should improve visibility when we go back there, and we're intending to go back there in October, in fact. So hopefully people will be confident enough to go there. That Beacon don't have any particular protocols in place for, so it's really up to us in terms of social distancing and mask wearing and things. So I think it depends if people feel comfortable, and obviously people can wear masks if they prefer. Because of the bookings that the Beacon is having, rather than try and compete with the Wantage Rock Choir, which now has a booking for Tuesday nights, we've decided it might be better to change the night, and Thursday seemed to be the otherwise quietest night of the week in the Beacon. I mean, there will still be exercise classes going on around things, but so that's why we're moving to Thursday from October, and the talk will be on renewable energy in October, and I think the speaker is just here actually and may want to give a little pitch, very short. I will hand over to him.
Could that be a relative?
No, nothing to do with me, John, nothing at all.
Yeah, I'm Damien Closhaw, and I'm excited to be the first speaker who'll be back in the Beacon, in the flesh, as it were. And I hope to be able to use that venue to make the talk a bit more interactive, perhaps, and be able to stand up and wave my arms around and
Pretend to be a windmill.
Pretend to be a windmill, yes. So the title of my talk is Renewable Energy Nuts and Bolts, and from that you'll see that I'm an engineer rather than a pure scientist. So I'm more interested in what this stuff can actually do for us rather than very in-depth science, but it's a big subject with lots and lots of questions. Just a snippet of a few that I might try and answer in my talk. So why is it that if you're a wind turbine, size matters? And how have wind turbines managed to become the cheapest source of electricity generation in this country? Another one, what about the magic of solar PV panels? You know, this is a bit of glass, silicon base materials. You just put it outside and it produces electricity for 20 years plus. It's amazing. Another one, why is it so fundamentally difficult to harvest the energy from the waves in the sea? Why is that such an engineering problem? I'll explore that. And finally, on these snippets, how are we going to heat our homes in this zero carbon world? Can we really get energy from fresh air using a heat pump? I'll leave those questions with you, and if you're interested, come along.
Okay, thank you.
What a brilliant trailer, Damien. Thank you for that.
So hopefully we will have an audience in October, but we'll see. Yeah, obviously there will be a bit of nervousness. We did also ask the Beacon about possibly doing hybrids things, but I think that is quite tricky actually. They weren't keen at the moment, well, yeah, to arrange that. So I think we're going to have to play it by ear for a bit, and it may be that some speakers would rather be on Zoom anyway, so we might use that again for some people, but that's the plan at the moment.
And hey, that means we're building back better. Heard that before? Thank you, Phil, for the big screen. We're relying on quantum imaging technology still to see around the pillar, but okay, one thing at a time. And trying to wrap up and say a huge thank you, Tim. It really was special having you tonight and giving this talk. And it is so exciting, the prospect of Natural History Museum coming to the campus just down the road from most of us here. And we really, really look forward to welcoming you and all your colleagues to the community here. I think it's going to be exciting stuff for another generation to come.
Thank you, John, and thank you, everyone.
Oh,
thank you, Tim.
We missed a thank you, Tim. Thank you to Esther, your colleague, who is very helpful making this all happen. So
yes, she's the woman I must obey. So thank you. Yes.
Fantastic.
Yeah.
Thanks everybody for joining us, and look forward to seeing you all again soon. But thank you, Tim, and good night to everybody. All the best. Bye-bye.
Good night.
Bye.